if you were to look at the cross-section of a satellite dish, it'll be in the form of a parabola, the shape right here, which is good news because what that means is any satellite beam or ray, whatever comes down and hits the surface of that parabola, would bounce into the focus where that piece is located, which is the whole point of the satellite dish. And so we are given the description of a satellite dish, at least the cross section of it, and asked to determine where should we place that receiver. In other words, they ask us to find P, the distance between the vertex and the focus. So let's go ahead and use the description up here to see if we can answer this question. So I've drawn the cross section of a parabola over here on the left. Now, if we were to put this on a coordinate grid, a graph, we can be very, I guess, wise about where we place that parabola. And what I'm going to do, I'm going to put the graph over this. I'm going to make sure that the vertex of my graph is right there at the origin at 0, 0. And that actually makes this problem not really that terrible at all to do. So that point's at 0, 0. Let's go ahead and add some numbers in this graph and see if we can figure out what we need to do with it. So here are the only two things they tell us. They tell us that the dish is 12 feet across at the opening. So the distance from here to here needs to be 12 spaces. Okay. And again, I was very careful about how I decided to place this. I could put it however I wanted to, but I made sure the center was right at 0, 0, meaning it's a distance of 6 spaces to one end. Is that 6 spaces? 1, 2, 3, 4, 5, 6. That's correct. So I'm trying to find a coordinate of this point right here. Well, since it's exactly 6 spaces over, because I was careful how I placed it, it's going to be 6 comma something. So let's see what else we know. Let's see if we can find that y value. They tell me that the height of the dish, or the deepness, I guess, the depth of the dish, is going to be 2 feet deep. So the distance from top to bottom right there is 2 feet. Well, again, because I was very wise about where I placed the vertex, that y value right there needs to be 2 spaces. So I know that I know 1 point of my parabola. Actually, I know 2 points because I placed the vertex at 0, 0. But more importantly, I know this point right here is at the point 6 comma 2. So actually, just using that piece of information, I can find where the p value should be, where I should place the receiver to get all the information. Since this is an upward opening parabola, I'm going to use the x squared model. And if you want to look back at our last videos or check out your notes, you see where I get this equation from. So x squared would equal 4 times p, which is what we're trying to find, times y. Notice I don't have like the normal y minus k like I usually have, because the k value was 0 this time. We were smart about where we put the vertex. So using that this model, let's go ahead and plug in our 6 and 2, which represents our x and our y values, and we should be able to find p, the distance we're looking for. So x is 6. Half of the length of the parabola. So 6 squared would equal 4 times p times the y value, which is 2, and you can see that this is not a terrible equation at all to solve. So 36 would have to equal 8 times p. If I go ahead and divide both sides by 8, I find out that p comes out to be 4.5, which is the answer that I'm looking for. And I guess to be specific, I specifically want that to be about 4.5 spaces above, or 4.5 feet. I guess I should say for this one, 4.5 feet above the vertex, or above the parabola. That's where the focus will be. That will be the location that receiver should be. What am I trying to say here? Above the vertex. That's the distance I want to make sure that all those beams that come in are sent right to that focus.